Every business depends on rules and documents like this credit policy, with rating bands, knockout rules, and sector adjustments. The challenge is getting software to follow them. This is the Leapter lab, our cloud environment with nothing to be installed. I could model the policy here by hand, and this is what that looks like. One condition, one branch, one clause at a time. This is how it usually works. Even with rule engines, someone still has to translate the document step by step. After hours of work, I have barely covered the first part of it. So instead, let's give the policy to the agent. Take each section and turn it into logic. Keep the policy's own wording and watch it build. The knockout conditions, the banding step, the rating table, and the decision mapping. So let the agent do the work. Here's the result. Underneath every blueprint is Veritas, a readable text-based language. The diagram and the text are a single artifact. Nothing is hidden in generated code. Notice the shapes. The threshold checks became branches, while the rating grid, where a combination of bands decides the class, became a decision table. It reads back as a literal specification, with logic and explanation woven into a single document. It's written for a human and still fully executable. Each table row is a scenario a credit officer can check line by line. Now let's run it. One application, thin margin, weak collateral. I enter the raw figures. The blueprint derives the ratio itself and runs. The decision comes back declined, with the exact rule that drove it stated in plain rationale. And I can see why. Right on the diagram itself, every condition is evaluated, every branch is taken, and every intermediate value is shown. This isn't a log to decode. It is the decision replayed directly on the logic, a graphical debugging, so to say. You can step forwards and backwards. This gives you the insights to prove whether the AI has understood and implemented your initial intent correctly. The agent also drafted a test suite alongside it, a case for each rating class and both knockouts. One click runs them all against the expected outcomes. Now let's implement a change to the logic. I ask the agent in plain language to treat cyclical sectors more conservatively. No thresholds are given, only intent. It works the intent into a blueprint, touching several steps at once, and I don't have to take it on trust. Every change appears as a diff, with old logic in red and new in green, so I can review exactly what changed before anything is approved. Once approved, the logic is ready to use anywhere. Every blueprint exposes a REST API and an MCP endpoint, so applications and AI agents call the same approved rule instead of re-implementing it. That gives you one source of truth wherever the decision is needed. And once it's in production, real applications run through that same logic deterministically. Same input, same output. There's no AI in the execution path. Any past decision can be replayed against the exact version of the logic that ran it. AI drafts, humans approve, and execution is deterministic. Next, we open the Insights panel. Every decision the blueprint makes is recorded so we can use it for analytical insights into my policy. At the top is the summary: 57 runs, all successful. Second, again, all the recordings of the production runs. This view is the one that really adds value. Execution share is mapped directly onto the logic itself, showing how often each rule fired and how often each row of the rating table matched. This reveals which policy scenarios carry the real volume and which rows never matched a single case. That becomes a policy conversation, and you can't have that conversation when your rules are buried in code. Features are the easy part. What determines whether logic like this reaches production is governance, and that's where our approach differs from a classical rule engine. Because a blueprint is text underneath, change can be governed in two ways: Either the workflow lives here in the tool with drafts, review, and approval rules, or you connect the project to Git and follow your own workflow there. On a Git-connected project, moving to review opens a pull request instead. Here, I'll use the in-tool workflow. There are 6 approval rules, from test coverage to syntax validation. We'll focus on 2. First, the 4 eyes approval. A second human has to sign off. Then there's the AI semantic validation, where the agent reviews the change against its stated intent. Each rule can remain advisory or be enforced, blocking the path to main until it passes. I apply these settings, and from this point on, every change follows these rules. Now it's time to make a change. Right now, I'm on main. The version production is running. I make a random change. That causes the tool to create a draft version. Every edit I make is captured in this stream's timeline, tracked one by one from the very first change. At this point, I'm working in my own stream. In this new window, we're not looking at my browser. This is my colleague's browser. I've invited him to my workspace so he can see my projects and open them. He opens the credit policy project, and like everyone else, he lands on main. My draft doesn't affect main, so to join me, he switches to my stream. From there, we're in the same place. My avatar appears in his window, and his appears in mine, so we always know who else is in the blueprint. The editor is multiplayer by default, not a mode you have to turn on. Now he makes a change, and it appears in my view the moment it happens. I follow up directly on top of his. Think about what isn't happening here. There's no lock in the file, no waiting for a checkout, and no export-import round trip that ends in a merge conflict at the end of the day. It's 2 people, 1 blueprint, 1 shared state, with every edit already tracked. And the timeline captures all of it. My edit, his edit, then mine again. Who changed what and when is all there. Now I want to bring the changes from my stream back to main, so I start the review process as defined in project settings. For the manual review, I first need to assign a reviewer and then request an approval for my changes. Depending on my setting, I can now see which reviews are pending. When I switch to my colleague's browser, he also receives the review dialog and starts his review process. This is the review screen. The diff summary lists every change, 2 modifications, node by node. By clicking into it, I can see exactly which conditions and expressions changed, not just that something changed. If I'm satisfied, I can approve. Back on my screen, I can see that the 4 eyes approval has now passed, while the AI semantic validation is still pending. So I start the agent review process. Once it finishes, I can see several findings from the agent logged in the comment section. I could apply those changes, but for now, I'm satisfied and approve them as they are. The comments are cleared, and my review process is finished as well. Now that I have all approvals, I can save the review and my draft is switched to main.